Welcome back. We're going to cover some factoring polynomials today. There's a couple things we're going to cover in terms of reviewing factoring. That'll be in another video. But there's also part of the remainder theorem, some of that synthetic division we're actually going to cover first. So if you struggle with synthetic division, you might want to go back and check that video out. Or maybe stick around this one and see if you can pick it up. But our remainder theorem, we said that we could plug in A and try the remainder theorem for the synthetic substitution with that value A, and the remainder would equal the value of P of A, meaning that you would plug in that number into the polynomial and get the same answer out as you would get as the remainder, which is kind of neat. But what we're going to do here is we're going to use that same principle to figure out whether or not a polynomial such as x minus a is a factor or not of our polynomial that we're looking at. Okay, and the way we're going to do that is if the remainder is 0, that means that polynomial is a factor and the a value is a solution or a 0 or root, whatever you want to call them. All right. So let's jump to an example and we'll kind of explain as we go. Okay. Is x plus 1 a factor of x squared minus 3x plus 1? So to determine this, we're going to use the synthetic substitution or synthetic division process. And if the remainder is 0, then it is a factor. If the remainder is something else, it is not a factor. So let's jump into our synthetic substitution, shall we? Or synthetic division is the same method. This is my a value, remember? But it's always opposite. We always stick, in here we put it as the correct a value, but it's opposite of this number here. So we're going to stick a -1. -1 is actually the correct a value, but I just always say negative a here just to remind you that you're changing this sign. All right? All right, and then we need the coefficients of the polynomial. So 1 for 1x squared, -3 for -3x, and then 1 as our constant. And again, if you're skipping any terms, like if you go from x to the third to x to the second, to x, and skipped x to the second, we would have to insert a 0 in here to fill up for that missing space. All right, but we're not missing any terms here because we go from the x squared term, which is degree of 2, the x term, which is degree of 1, and then our constant, which is degree of 0. So we're clearly not skipping anything. 2, 1, 0. Nothing's missing. All right, so to set up properly, what we're going to do, we always bring down the first term. So that 1, we're going to carry it down, or bring it down there. Now we're going to take that 1 that we brought down and multiply it to our a value, -1. 1 times -1 is -1. And we put that value above the line, right below -3, kind of in sequence to our next terms. Now we're going to add these two, -3 minus 1. And I know I said add, but when you add a negative, it's like subtracting. So -3 minus 1 is -4. Now we take -4 and multiply it to my a value, -1. -4 times -1 is +4. We stick it back up there. And we add these again. All right, so I have 1 plus 4, which gives me 5. All right, now I'm done. This 5, the very last digit here, marks my remainder. Since my remainder is not 0, x plus 1 is not a factor of this polynomial here. All right. If the remainder is 0, then it is. If the remainder is not 0, it is not. And that one was not 0, so it is not. Let's look at the next example. Example B. Is x plus 2 a factor of 3x to the 4th plus 6x to the 3rd minus 5x minus 10? Well, we're going to use that synthetic operation, synthetic substitution again. So here is my quote-unquote a value. We're going to change the sign when we put it in our little box there. So again, technically -2. This is the correct a value, but I always label it -a just because I want to remind you that we're changing that sign. All right, so let's get into it. Now I need the coefficients of my polynomial. So 3 for 3x to the 4th, 6 for 6x to the 3rd. Now, there is no x to the second term, right? So I'm going to put a 0 in for that x the second term that's not here. Then we'll move on to the x term, which is -5, and then our constant, which is -10. All right, so you notice how we went from exponent of 4, exponent of 3 to the exponent of 1, right? We skipped the x squared term where it wasn't in the problem. We have to make sure we include that, okay, in our synthetic substitution work here. All right, so everything's there, everything's in order. Let's begin our process. The first term we always bring down, that never changes. So the 3, we're going to bring it down below our line. Now we take that 3, we multiply it to my a value, -2. 3 times -2 is -6. We insert that value right above the line. And now I add these terms to get the next successive term. So -6, or sorry, 6 minus 6, same thing, is 0. Now I take that 0 and I multiply it to my a value. Begin the process again. 0 times -2 is 0. That 0, I bring it up, and I add 0 plus 0. So here 0 plus 0 is 0. Put it down there, repeat the process, multiplying 0 times my a value. 0 times -2 is 0 again. So I bring that value up, and now I add -5 plus 0. So -5 plus 0 is still -5. Now again, I take -5 and I multiply it to -2, my a value. That's giving me a positive 10. And of course, -10 plus 10 is 0. So I'm done. Notice what my remainder is here. My remainder is 0. So that means yes is our answer here. X plus 2 is a factor. And not only that, but that means that -2, which is the a value, is a 0, aka a root, aka a solution, whatever you call those things these days, okay? That just means that this polynomial, if you were to graph it, since x plus 2 is a factor, and -2 is a 0, that means that that polynomial would cross the x-axis at -2. That's what I mean by 0 or root, is that -2 is an x-intercept for that polynomial. All right, we're going to skip ahead here. Oops, sorry. And you get the kind of the idea. I think there's one I wanted to show you here. Let me show you the second example on this real quick because it's a bit odd. All right. Is 3x, I'm looking at this one by the way, the one on the right. Is 3x minus 6 a factor of 3x to the 4th minus 6x to the 3rd plus 6x squared plus 3x minus 30? All right, now here's the thing. We can't really do the synthetic substitution on that type of polynomial because it has to be in the form x minus a, x minus or plus a. But we simply can't have like a 2x or 3x like we do here. It has to be just a plain x. All right, and this is not like that, right? Because it's 3x. So what we're going to do is we're going to factor that 3x out first, or the 3 out first. Notice that that binomial of 3x minus 6, both terms here have a GCF. Both terms are divisible by 3. So we're going to factor this 3 out of it, right? And then what we'll have is 3 divided by 3 is going to leave us with 1x, and then -6 divided by 3 will leave us with -2. So this is what we're going to use, okay? The 3 is technically a part of it, but we're not using it now. We're going to stick with this factored result, and we're going to play with it, right? So that makes my a value 2, right? We have to change the sign here. So that's going to go in my box. Now, there's two things you can do, and it's not going to matter either way. You could also factor a GCF out of this polynomial, the big long one, 3x to the 4th minus 6x to the 3rd plus 6x squared plus 3x minus 30, but you don't have to. All those terms are divisible by 3, and you can factor 3 out as well. But we're going to get the same result regardless, so I'm just going to not worry about that. I'm just going to go ahead and use the coefficients that are there. So we have 3 for 3x to the 4th, -6 for -6x to the 3rd, 6 for 6x squared, 3 for 3x, and then -30 for -30. Now, I wasn't skipping any terms, right? 4 exponent, 3, 2, 1, and then my constant. So no terms missing, no zeros needed. Everything's set up properly. Let's begin. Bring down the 3 as always. The first term never changes. You take that 3 and multiply it to the a value, which is 2, positive 2. 3 times 2 is 6. Now we take -6, add that 6. -6 plus 6 is 0. Multiply again. 0 times 2 is 0. 6 plus 0 is 6. 6 times 2 is 12. And 3 plus 12 is 15. 15 times 2 is 30. And negative 30 plus 30 is 0. So, notice what my remainder is. My remainder is 0, which means that x minus 2, my binomial here, is a factor. And also, that means the a value, which is 2, is a 0, aka root, aka solution, whatever you want to call it. Okay? Again, that just means when I say 2 is a 0 or a root or a solution, it means that that is an x-intercept. If you were to graph that polynomial, it would cross the x-axis at 2. Probably crosses at a bunch of other points as well, but it does cross guaranteed at 2. All right. Moving on, I think I'll cut this video here, and I'll put this in a separate one so they don't get too terribly long. But next we're going to actually start talking about factoring. But I encourage you to review or re-watch or go over the factoring review video that I'm going to put up so that, you kind of remember. Because it's been a while since we've done factoring, so the review might help you a little bit shake some of that rust off. All right? I'll see you again in another video. Bye-bye.